Now, the first case study that I wanted to present was on beverage cans. So, as I said earlier, Novelis is the world's largest producer of flat rolled aluminum sheets. 50% of our revenues come from selling flat rolled aluminum sheets to the beverage can market. And as you can see, the modern beverage can is a highly engineered product. Uh, I mean, in fact, I can easily say that this is one of the most engineered products that you will ever lay your hands on in day to day life. And the next most engineered product is probably the space shuttle or something like that. Nevertheless, here what we have within Novelis is a formidable capability in modeling beverage can making using the finite element method. So the finite element method is a computational method for understanding the mechanics of deformation during can making. So each of these finite element models, they take several hours of computational time. And what we have done is that we have actually parameterized the beverage can geometry as shown in the pictures here. And we have about 40 odd parameters in this model. Sorry, it's written here, it's 26 parameters that we have. And the target response that we are after is the best possible dome reversal pressure that is shown in the animation here, the pressure at which the dome actually pops out. The bottom dome of a beverage can pops out. So that is not the way to go. If our aim is to find the best possible design that will give us the highest design of experiment, we actually thought that we should be using a more intelligent way of solving this optimization problem, and that's where we started using SigOpt. Here is an example where we ran where we ran a grid search of 15,000 simulations, and the highest dome reversal pressure that you see, this is in bars now. The highest dome reversal pressure was somewhat like a 8 point odd bar, or it's actually around 7.5 hours. And this was out of 15,000 simulations. And what we did was we started using SigOpt, and we saw that we could actually achieve this a better result with a fraction of the number of simulations that we had already spent by using grid search. So actually, there were in this model there were two target properties that we were trying to optimize. One is the dome reversal pressure, which is shown in the animation here, as I said earlier, and the other one is the column strength of the beverage can. So how much load can a beverage can actually take when you load it actually. So that's what is plotted on the x-axis here. So here is an example where with we using SigOpt with the least number of computations or observations, we were able to find a better design than what is currently commercially available.